Can you hear? They are beautiful, colorful, they look like ants on steroids, and their sting can make you wish you were dead. Zhronki, because that's what we're talking about, are insects you may have never heard of in your life. However, because of their lifestyle, diversity, and the fact that they are practically indestructible, I think they are some of the most amazing stinking insects we can find in Poland. We'll start the story with this container, which of course contains a Zhronka. This Zhronka came to me basically by accident, thanks to the keen eye of my friend who simply spotted it during one of our field trips. And this is the main character of today's episode. The Zhronka that I got, which is in this very heavy container because there's sand inside, is a female Mutilia marginata, also known as the white-legged Zhronka. And this particular species is one of 7 that we can find in our country. And that's quite interesting, because our native fauna, since it consists of only 7 species, is just a tiny fraction, not even 0.1% of all the Zhronka species in the world, of which there are almost 8,000 species worldwide. Zhronkowate, or the Mutilidae family, are stinging insects. And we could say, in quotation marks, that this is a family of wasps, even though they don't resemble the classic wasps, meaning the Hymenopterans from the Vespidae family. Zhronkowate have a few features that are quite unusual when it comes to the entire order of Hymenopterans. And the first of these features is that they are parasitoids. That means they feed on other species. Mainly, these are species of other Hymenopterans that nest in the ground. However, as with most rules, there are always exceptions to be found. And for example, the wasps from the genus Papognatha don't prey on ground-dwelling species, but on those that have their nests in trees. And among others, these are the so-called orchid bees, which are beautiful, green, blue, shiny, and so on. Another quite amazing example is a wasp that can very rarely be found in Poland. In general, it's a rare species, and I mean the European velvet ant, that is Mutila europea. It, in turn, feeds in bumblebee nests. And it looks more or less like this. After mating with the male, the female velvet ant finds the nest of her potential host, enters the nest, and as if nothing happened, lays single eggs in places where the pupae or larvae of various Hymenopterans live. And then, if a tiny velvet ant larva hatches from that egg, it gets right to eating. Someone might wonder, okay, but let's say there's a bumblebee nest, and there are a lot of female bumblebees there with stingers who can defend the nest. So how does a velvet ant, much smaller than a bumblebee, manage to get in, lay her eggs without ceremony, and just leave? And here we come to the second fantastic trait of velvet ants, which practically all velvet ants possess. And that's their range of defense mechanisms, which is why some people call velvet ants indestructible insects. And they really are practically indestructible. Starting with their structure, as we know, the exoskeleton of insects is made of chitin. However, velvet ants have so much chitin, and their exoskeleton is so hard that practically no stinger or mandibles can pierce or bite through this armor, and so on. Even entomologists who study velvet ants have found that it's difficult to pin these insects because steel pins simply get damaged when they come up against their armor. And that's the first thing. The second thing is that since velvet ants are stinging insects, it means that the females have stingers. Of course, males don't have stingers, because a stinger is nothing more than an ovipositor that has evolved over time, a special organ used for laying eggs. So velvet ants have stingers, and this female also has a stinger. What's more, these stingers aren't just little bumps like those of wasps or hornets. These stingers are sometimes almost as long as the entire velvet ant. And not only are they long, but velvet ants can maneuver them any way they want. These stingers can bend. They are incredibly sharp, and besides being sharp, the venom that velvet ants inject causes tremendous pain. And it even gets to the point where one of the velvet ants, specifically Dacimutila klugii, was placed in the honorable 4th spot on the Schmidt Pain Index. That means its sting is insanely painful, and that's for real. The pain, while lasting up to 30 minutes, feels like a red-hot nail under the skin. It's very painful. Personally, I once had the misfortune of being stung on the finger by one of these giant hornets. Years ago in Greece, I decided to grab one of these giant hornets with my fingers, despite the obvious risks. And that's when I got stung, and believe me, it wasn't pleasant. If anyone is wondering why hornet stings are so painful, if I had to guess, it's because of the presence of acetylcholine in their venom. The venom composition of only 5 Deishimutila species from the United States has been analyzed, while most species remain unstudied. The venom mainly consists of peptides. However, I suspect that acetylcholine is what causes the intense pain. Another defense mechanism is that they can make sounds. Yes, these little steroid ants can stridulate. And this stridulation doesn't only happen if we touch them with a finger, because they can see, more or less, since they have compound eyes, they can make sounds when an attacker is already about a meter away from them. And to confirm my words, I'll mention tests that were done on solifugi and shrews. Shrews, being insectivores, would readily consume a solifuge. But when the shrews were about a meter away from the solifuge, it turned out that the solifuge started to stridulate, and the closer the attacker got, the more intense the stridulation became. I'll try to record for you how it sounds. Can you hear it? And that's more or less the sound made by Zhronka. So yes, they're venomous, they can sting, they're armored, and nothing will eat them. They have the ability to make intimidating sounds, and if anyone asks if that's the end, it's not. Absolutely not, because many species of Mytilidae have developed what's called aposematic coloration. This means that through evolution, they developed very contrasting bright colors, so that any potential predator would know that if it tries to eat them, it will end up with pain at best. To confirm its effectiveness, multiple tests were conducted, including on birds. And here, well, to avoid causing the death of birds, they simply painted mealworms the way nature paints the burnet moths. And what turns out? It turns out that birds, using their eyesight, could tell which ones were painted and which ones weren't. And of course, they devoured the unpainted ones like crazy, while the painted mealworms were avoided by the birds. I mean, there were some attempts to attack, but none of the mealworms painted to look like a wasp were eaten by the birds. And that means birds also know that these colors mean pain or something worse. Moreover, tests were also conducted on lizards, for example from the genus Uta, and these lizards after they tried to attack such a wasp, because here there was an attempt to attack and an attempt to eat. And what's more, later the lizard from the genus Uta was stung by the wasp. The result was that the lizard was found dead after 24 hours. So this also shows that this venom, let's say, is quite strong. It won't do much harm to a human besides causing pain, but, well, wasps can defend themselves. So to sum up, they are simply tanks in the world of insects, and beautiful tanks at that. Here on my list, I think the first place is held by the genus Dasymutelia, which can be found among other places in North America. And the velvet ants from the genus Dasymutelia have beautiful colors. They can be very hairy and white, they can be red, they can be brown, and their coloring is just amazing. Very beautiful velvet ants can also be found in Africa, but I think our European and local species are just as attractive in appearance. Another thing, velvet ants sometimes cause quite a lot of problems for taxonomists and entomologists. Why? Because one of their most recognizable features is sexual dimorphism. We've already discussed obvious differences between male and female bees, such as the presence of a stinger in females and its absence in males. However, in their case, there's a situation where the females, which you can see now on the screen, because this is a female, don't have wings, and they just walk around on the ground like this for their whole lives. On the other hand, males can fly. Why do they fly? Because they have wings, right? Do you understand that? Males have wings, females don't have wings, and this is such a huge difference that sometimes people who study velvet ants and entomology wonder if a given male and female are even the same species. Only by observing these species mating can you confirm, okay, they're the same species, because otherwise you can't tell. They're so drastically different. And then there's the diet. The diet, as you might guess, since they're parasitoids, the diet of the juvenile stage, meaning the larvae, consists of meat. They feed on the host, eating the larvae or pupae of other hymenopterans. However, the adults aren't so bad at all. They won't hunt us, they won't bite us, because adult Zhronki feed on flower pollen. And here there's some uncertainty, because while the males, which actually have wings, have been observed feeding on flower nectar, I couldn't find any information about what the females eat. There's a suspicion that they also feed on flower nectar, but I can't really imagine a situation where a female finds a flower and has to climb onto it just to feed on it. So it's possible that they simply eat some other kind of plant food, but I still need to educate myself about that. To sum up, there's no doubt that these small insects, sometimes 1.5 centimeters, sometimes 1 centimeter, and sometimes even 3 centimeters long, because that's about how big Zhronki can get, are some of the most remarkable examples of, first, aposematism, second, survival skills, And third, they're simply a beautiful example of entomofauna that we can also encounter in our own backyard. Thanks for watching. Let me know in the comments which insects you want to hear about next. See you in the next video.
Hey,